Along with the if-else, we have surreptitiously introduced another feature of the language, which is the block of instructions. So what is it and why do we need a block? Well, our instructions so far have all been the same. So in a way, if you think of running a list of instructions from the top to the bottom, there is no particular reason to group them in any way. But what we're doing here is we are allowing our code to branch according to the data. So sometimes it may happen that in each case only one action needs to be taken, while in other cases you may want to have to take more than one action in one or in both cases. Now, how are you going to kind of specify what are these instructions that should go together and should be taken in one case? Well, enter the block. The block is present in most programming languages, but it's demarcated in different ways. So normally, in a language such as Java, you would, or C++, you would, for instance, do something like that. You would open curly braces here and say, okay, look, after the if, I have a set of curly braces, and whatever is inside those curly braces must run if the condition is true, and the same for the else. In Python, there are no such braces. So as you've probably figured out by now, the role of the braces is taken by indentation, simple indentation. So if you tried running this code, you will have seen it doesn't run, and it doesn't run because that print brew is not indented. And then obviously gives you another error on that, on the else clause, and here we are, it runs correctly. So you see the indentation here denotes that brew is inside the block that's kind of controlled by the if statement, and wait is inside the block controlled by the else statement. Now these blocks are kind of trivial because they consist of only one keyword, but if we look at this example, it's no longer trivial, and you may have tried it, you may not have tried it, but see what happens here. You see the temperature is 90, which is not 100, and so this part of the code runs. It prints Boyle's law, well, my version of it at least, and it prints this line. Now, this line is not inside this block, so this line actually is not controlled by the else. So that line would always run, no matter whether the condition is true or it is false. You see here the temperature is 100, so the condition is true, and it actually prints boiling, which is this block, but that line is outside the block controlled by the else. Therefore, sequential execution resumes, and this is printed. What happens now if we change that? Let's say we indent this line. You see it no longer runs because the else branch does not run. Now conversely, let's move it back to where it was. So now when I run this code, this runs and also that runs. If I pull out this line so that it's also outside the if, see what happens. Nothing changes as long as I am in the else case, because it prints that and then it runs all the rest. But if I now change back the temperature to 100, it prints boiling. It doesn't print Boyle's law because that's controlled by the else, and the condition is true, so the else branch does not run. But it does print a washed kettle never boils, and it prints ending indentation will end the block, because these two things are not indented. Incidentally, this fact that indentation is part of the syntax of the language in Python is, as I said, rather unusual, but it's a nice feature of the language because it forces you to write programs that are well indented and therefore, as you will soon realize, very easy to read. Some people don't like it, but in general, I think it's a plus. The only time where you can get caught is if ever you're cutting and pasting a bit of code from one part of a program to the other part of the program. You have to be careful that when you paste it in, you do not change indentation, but most Python editors are smart enough to take care of that.